right, so let's look at these problems in the practice for today. The first one says combustion. So we're already told what type it is, and combustion makes it very convenient for us because we already know what those products are going to be. So we have C6H12 plus O2, and what is that going to yield? Well, every time we have combustion, we know that we have a hydrocarbon plus oxygen, and it's going to yield every single time CO2 plus H2O. So it doesn't matter which hydrocarbon we have, we are going to have the products CO2 and H2O. Now, the thing that's going to be different is our coefficients, because part of this worksheet tells us that we are supposed to balance the chemical equation. So if we look, we can see that there is 6 carbons in the reactants, and there's only 1 carbon in the product. So I'm going to go ahead and put a 6 here, and that gives me 6 carbons. I can see that I have 12 hydrogens, and I only have 2 hydrogens in my products. So I need a 6 here as well. And then I need to look at my oxygen. I have 6 times 2 is 12, plus 6 times 1 is, so 12 plus 6 is 18. So what does my coefficient on oxygen need to be? So if I have 2 as my subscript, 2 times what gives me 18? 9. 9. So your coefficients are going to be different, but every time you have combustion, you're going to have carbon dioxide and water as your products. Okay. All right, so this is what you should have for B and C. B kind of threw us off a little because it looks like you could just say, oh, I need 4 carbons and I need 3 for hydrogen. But what that does, when you have 3 times 1 for the oxygen, you get an odd number. And because we have a subscript of 2 on the oxygen in the products, you can't have an odd number. So we have to make it even, and you do that by putting a 2 in front of your hydrocarbon, and then that gives you 8 carbons and 12 hydrogens, and that allows you to get the 8 times 2 is 16, plus 6 is 22, so 11 times 2 is 22 for your reactants. This one threw you for a little loop because we have an oxygen in our reactant, in our hydrocarbon. And so what we have to do is consider those 3 oxygens there. We get 6 carbons in our products. We needed 10 hydrogens, so 5 times 2 is 10. That gives us 6 times 2 is 12, and 5 times 1 is 5. So 5 and 12 is 17 oxygens. And we think, oh, that's an odd number, that's not going to work, but we have 3 here. So 17 minus 3 is 14. We need 14 oxygens here, and that's where we come up with that. All right. So let's discuss some of the other problems on this problem set. The first one here is synthesis. So we're told that it's synthesis, and let's talk about how do we know that it's synthesis? Because like I said, you guys had to do these on a snow day. So synthesis, we have 2 elements. So 2 single elements that combine. We start with 2 single elements. We're given magnesium and iodine. Now we know, we talked about the other day, iodine is a diatomic, so it can't exist by itself. And it's going to yield, well, what is it going to yield? How do we know what it does? We know they're going to combine. We look at magnesium makes a +2 charge. How do you know that? Well, we come back to our periodic table. Magnesium is right here in the second column, So it has a +2 charge. It's going to lose 2 electrons. Iodine is going to make a -1 anion. So the way that it's going to come together is actually super convenient and a little bit deceptive, but we're going to crisscross and we're going to come up with magnesium iodide. So it looks like we just smashed them together, but we didn't. We had to think about the charge and how that ionic bond would form. Okay, so don't be deceived by the fact that this one looks super simple. All right. Let's keep going so that you have some time to work on your own. Did I do that one? Yeah. All right, so double displacement. We know that double means 2. And it might be double displacement or double replacement. It doesn't really matter, whatever work you're using. But they're going to change partners. That's the easiest way to remember. And so we're given copper chloride and sulfuric acid. And we're thinking, well, how do I know how that's going to come back together? Anytime we have double displacement, we know that we're going to need a cation and an anion. Most of the time, they're ionic compounds. So we have the first and the last. That's the easiest way to think about it. The first and the last, and then the first and the last. Okay. So, all right, if I'm going to put copper together, I look at my cheat sheet and I say, well, copper can make 2 different things. How do I know which one it is? It can be +1 or +2. Rewind your crisscross. So we know that copper had a +2 charge, and we already knew that chlorine had a -1 charge. Okay. And hydrogen we know has a +1. Sulfur, I'm going to bring it in, is a -2. So now we can form our new compounds. We're going to go with copper and sulfur, so the first and the last. Copper has a +2, and sulfur has a -2, so they're going to cancel each other out. Hydrogen has a +1, chlorine has a -1, so they cancel each other, kind of. We know that we don't need those subscripts. Then we look and say, all right, I have 2 chlorines and 2 hydrogens. I need a 2 right here. And then I have a balanced equation. Okay. So the big deal on these is to make sure that you think about how do the compounds form and what are you going to make the products with? First and last, and first and last. Okay. All right. The next one, I know it's another double displacement, but I do want to touch on this number 3 real quick. We're using that same concept. We're going to change partners. And hopefully you already understood this, but when we look at it, you might be thinking, well, there's three elements there. How do I know what partners there's changing? Well, let's write it down and discuss it. Okay, we have sodium hydroxide plus hydrochloric acid. Okay. Well, what is it going to yield? I know, let's see. If I look at my cheat sheet and I say, well, I know that we're talking mostly about ions here, and I know that sodium is the first, but the last. Is it oxygen? What is it? If I look at my cheat sheet, I will find that ClO4 is perchlorate. And it has a -1 charge. So this is a polyatomic anion. It has a -1 charge. So I know that sodium has a +1 charge because that is where it's at on the periodic table. Okay. So there's my first and my last. I'm going to come together and make sodium perchlorate. And then my first and my last, you might say, well, I didn't know OH was an ion. Well, look and see. There's hydroxide. It has a -1 charge. So you're going to have to come back to your cheat sheets if we don't remember them. Now, I could write HOH, but how do we normally write HOH? H2O as water. Okay. So then I look, 1 sodium, 1 sodium, 1 perchlorate, 1 perchlorate. I have 2 H's and 1 O. Okay. So it's already balanced for us. So this idea of polyatomic anions is really important too, or just polyatomic ions. Okay. So you remember that they behave as one entity. They behave as one thing. All right, one more, and then I will let you work on your own. This decomposition business, okay? Let's talk about decomposition for just a second. Number 4 says decomposition. Now we think about the word decomposition and we think about it as falling apart, but it can also be less complicated. So in this example, we're given zinc, CO3. What on earth? Well, we look and find CO3 is carbonate, so zinc carbonate, and it has a -2 charge. So -2. If we think about it, well, we could guess that zinc is then have to have a +2 because they canceled each other out. Or we could look at the periodic table, or we could look at our cheat sheet. Zinc makes a +2 cation. So they did cancel each other out. And then the heat should really be here as adding heat. What's it going to fall apart to? Now, this is where you might get stumped, okay? So you're looking at it, well, surely it's just going to be zinc and carbonate, right? Carbonate, though, when we look at in this ion, it has got a -2 charge. So it is going to bond with something. So you cannot leave just an ion. Otherwise, it's going to go back and bond with that zinc. So what it would fall apart to, you kind of have to be a little creative in thinking about this. What is a stable gas that you know that has carbon and oxygen in it? CO2. Okay. And then you have this oxygen that's left. You could still have 2 compounds. You would have zinc oxide. So, because if you try to balance it out with just CO2 and zinc, it might never happen. And that's where you have to be a little creative. I will not put a decomposition on the test, but I do want you to see that sometimes it decomposes from very complex to 2 simpler compounds, not just to 2 elements. So it's important to see that. All right. Give me a thumbs up if that makes sense and you think you can probably go on with them. All right. So there's a lot of problems on this worksheet. I want you to do at least 4 of them. At least 4 of them to submit for this assignment, okay? That I haven't done on the video. All right.